Hi, welcome to the next video of the Leetcode series at Adventurous Coder. I know it's been some time since I've uploaded, just few things going on at work, but I'll try to be more consistent going forward. Today we are gonna do first bad version. That's a Leetcode problem. Let's open it. It's open here. So let's go to the question as usual. You're a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after bad versions are also bad. Okay, so if you have a version 4 that's bad, that means 5, 6, 7, 8, and so on forth are also bad. Suppose you have n versions and you want to find out the first bad one, which causes all the following ones to be bad. Okay, so we have to find the first version that's bad. So somewhere it went wrong. What's that place? So you're given an API bool is bad version, which returns when whether version is bad. Implement a function to find the first bad version. Okay, you should minimize the number of calls to the API. Got it. So now let's look at the example. N is equal to 5. That means I have 5 versions. Bad is 4. Okay, output 4. Hmm, okay. Oh, so they don't give us that bad is okay. Uh, got it. So they only give us n. They don't give us bad 4. They only give the n is 5, and because that is what I see here, and we have to call that and we have to return 4. I think there's a problem with this, but okay. Now let's try to understand the problem. Today I have something to draw with. Let's take this as an example. 1, 2, 3, 4, 5. We know that fourth version is bad. That means the future ones are also gonna be bad. First thing we're gonna do is, well, the obvious answer is iterative approach. We keep checking. Is this bad? Okay. Then we check if this is bad. Then we check if this is bad. Then we check, yes, this is bad. That means this is the first bad version. Okay. So let's try to implement the iterative approach here. So it could be as simple as for int I equal to 0, I less than n, I plus plus. Well, incorrect. I is 1 because the version starts from this. I less than equal to n, I plus plus. Then we check if is bad version of I, then return I. Yeah, this seems very simple. Let's run it. Oh, we have to return by default, so that would still be n. We'll never reach this place, but let's just mention it as we would always have a bad version. Okay, our case is run. Now, will this pass as a will this pass in a submit or not? Now, if you have to talk about the time complexity for this is gonna be big O of n, correct? Because we are gonna be worst case scenario, you might have only the fifth one as the bad version. You'll have to still go through all the n elements to figure it out. Big O of n with 2 of 31 minus 1 would be good. Let's submit it for now. Let's see what does Leetcode tell us. Well, it is accepted. But now let's go to the main part of the question. That is, you should minimize the number of calls to the API. Right now, we end up making n calls to the API, which is not feasible. So, how do we approach this to minimize the number of calls? Let's take this problem again. 3, 4, 5. Let's say this is the bad one. This is the bad one. Now we're going to do something that's called as binary search, which is binary search, which is like divide and conquer. So that just basically means we're gonna take a low, this is gonna be our high, and this is gonna be our mid. So we check if a mid is bad or not. If a mid is a good version, in our next iteration, we only assume this as a new array. We forget that this part exists because we know that this is a good version. That means anything before it is also a good version. So our only problem comes down to 3, 4, 5. So we'll focus only on that. Then we'll go again at the mid. We'll find out that 4 is bad. Okay, if 4 is bad, our next uh, one second, yeah, our 4 is bad. So then our next array is gonna look like 3 and 4 because, well, we know anything after 4 is bad and we focus only on this array. So this is how we keep dividing the problem and then finding out where the exact issue is. So let's look at the implementation for this. So int low equal to 1, high equal to n. Okay, uh, then we are gonna do while low less than or equal to high. Let's do it that way, or not equal to, because what if low is equal to high, then it'll be in a repetitive loop. So why such that? Because let's say if my right now the low is at index 2, high is at index 3, 2 plus 3 5, and then uh, I rewrite my low as say 4 or 3. That means I only have one element in the array. I want to break the loop, so I'm just going to keep it at that case. What we're going to do is, if first is bad version mid. Now we need to calculate this mid. So int mid is equal to low plus high divided by 2. That is simple calculation. Then what do we do is, if it is a bad version, we make our high is equal to mid plus 1, else low equal to mid plus 1. That is, if it's a bad version, that means we know that anything after this element is bad, and if it is not, anything after this version is good. And then what we return is low. And let's run this and see what do we get. Do our test cases pass? Time limit exceeded, though that's a problem. High, mid, 5, bad. Now let's find out where the problem is. It should not be a mid plus 1 because this is, we know as a fact that this is where our version is bad. It passes. We submit. We ran into a runtime error. Low. Oh, okay. This is because they can't add big numbers. Well, we need to fix that. Now we fix that by changing this to long int, because now we know it's 2 power 31. So we do a submit, and yes, we got it accepted. That is it for today's video. We are good. Thanks for watching. Bye.